Okay, we're recording. So let me get the agenda up for today. Can you see the agenda?
Yep.
Okay, fantastic. Hey, Amir.
Hello, everyone.
Okay, just a minute here. There. Okay, so what we'll do is if this is your first meeting, if this is, I think, our fourth as a collective group. If you haven't introduced yourself yet at any of the meetings, including the first one, if you could just quickly introduce yourself. What side of the industry are you on? And what compelled you to be part of this study group? Scott, have you introduced yourself yet?
Yes, sir. Yeah, I was at meeting 2.
Okay, all right, perfect. Okay, looks like Jackson, did you introduce yourself already? I think you did.
Yes, I
Yeah,
did.
okay, that was the first one. And then last one is Ratchet. Have you introduced yourself yet at one of the meetings?
Yes, the previous one. Yep.
Okay, perfect. All right, guys and gals, thank you. All right, so this will be an interesting session. This will only last 1 hour. We'll be very careful because we have East Coast time on a Friday. We don't want people, going late. So we're going to start right off. And I encourage, today, I encourage discussion. And because we're going to talk about work breakdown structure and how important it is to not only the overarching methodology that the group is uh, looking into and coming up with process, but we're going to take a look today and discuss how important it is to adhere to the NASA protocol of work breakdown structure because it is so complex. I would argue that the work breakdown structure is the most important thing in the work that we're exploring for several reasons. But before we get into that, let's just briefly review the agenda, and then we'll get into. I'll do maybe about 15 minutes or so of work breakdown structure, how it applies to the theory that we put together, and then also go over some highlights from the NASA work breakdown structure handbook. So it will give the team kind of an understanding of the importance of us knowing that handbook, along with the estimating handbook, by the way. But I think if I had to put priority, it would be the NASA work breakdown structure. If we don't adhere to their methodology, their mandate, it can be very complex and essentially broken for many reasons. But we'll get into that in more detail. So let's start with the resources and need to call to action. Lens of expertise. As I mentioned in the last couple meetings, this is a interactive group that has lenses from all sides of the industry, private, public, along with some universities as well. Right now, we have 5 universities involved with this. Most of us on the call are practitioners in the industry, representing some fairly large companies. We're all thinkers, and we all want to. We're intrigued by this problem and this challenge, and it's just a privilege to be part of this group. It's an absolute pleasure, and it's an amazing learning experience also to hear perspective of lens. What you'll find is that we'll start talking philosophical and methodologies as we start refining the white paper, and I'll get into that in here in a little bit. But anyway, so the first one right away would be the lens of expertise. Now, because we have such a diverse group, if you haven't yet, please go into that Ann Liu, the intern for I4CI, has done a really good job on the data room, and everything's pretty easy to, very easy to find. You'll see the document there. It will only take you like a minute or less. And just let us know what your lens of expertise is, because that's where we'll ask for help on peer review of the white paper. And so that also you can focus specifically on a section of the white paper that is that you're considered an expert in the field. The white paper will also have very specific areas spelled out, so you would know exactly if you're an expert in unit cost analysis theory, then you would know exactly what section to go for. If you're integrated project delivery or means and methods, or production analysis, or whatever that is, you'll see a list. Please just let us know that you feel that you're a knowledge area leader in that sector. Most of you have filled it out, but not all. Not all. I think we're probably running 60%. Even if you're a bystander and you just kind of you said you just kind of want to hang out and show up to some meetings and just see what's going on, please still fill out a form. That would be great if you're on the email list. Okay, the next is, and again, you can go to the data room. It's very clear what that is. And I just have to trust everyone will do that. One last thing, sorry, and then I'll get off the first one. It makes organizational aspects on our side much easier, because we really want knowledge of what type of knowledge area leaders we have, so we can delineate and plan, because this thing is, as we all know, is pretty massive and it's comprehensive. And it takes it will take a team certainly to get through this. Resource submission. So as we get into this, all of us will come across resources that we read, whether it's through academia or professional publications, American Society of Engineering, or Estimating, American Society of Engineering, on and on. And so if you could, we'd rather have more information than less information, because it's very simple that we would be able to just go through it, comb through it. There's a little questionnaire. Literally, it will only take you a minute. Upload it with Ann Liu. And I believe, Ann, is there a place to upload, or do they have to go through you after they sign the form, or do they sign the form and then it automatically goes to you?
It'll automatically be uploaded once it is in the form. And I put the form in the comment for anyone that hasn't filled it out yet. So please take a minute to fill out both. Thank you so much.
Great, Ann, thank you. If you haven't had time to go through the data room, Ann is doing a really good job. It is so organized and so easy to get through documents. Even when I'm flying through documents and stuff, it's just easy. And that's purposeful, because everyone's busy and we want to make everything efficient. All right. So resource submission forms. I believe there's a note place where you can say why you think it's relevant, and we'll go through it. So don't worry about that. You don't have to get in the nook and crannies. We'll get into the papers, and then we'll put it either in primary reading, which is primary reading, as a reminder, is part of the theory and process. Secondary is kind of, but not necessarily integral piece. And then there's reference documents, which are kind of loosely related. And then as we get through them, we'll move it into a primary or secondary. Okay. Primary would be, if I had to categorize that, is we should, all of us on this team should at least poke through the primary reading. Most of it's NASA right now, and that's pretty important. But there'll be quite a bit of others, quite an expanded list from that as well as we get into. And I expect within the next 30 days, it will be pretty hefty. But we'll organize it in a way that that it won't be overwhelming to go through it. As I mentioned, we're very sensitive to all of us being very busy. Resource, okay, upload significant works. All right. So I'm reminded Dr. Brad Hyatt and Dr. Vishish Sain, University of Berkeley and Cal State University Fresno, they have dissertations that have sections that fit perfect on our on how this data or the methodology or the theory of what we're doing. Anyway, it fits very well. One is on predictive analysis in production using artificial intelligence. He just turned in his dissertation and received his doctorate degree 2 weeks ago. And it's Vishish Sain from UC Berkeley. It's just very ironic and strange how a section of his dissertation fits what we're trying to do exactly. Same thing with Brad Hyatt. I see Steve is on the line. Steve, you had an inquiry about how would we address risk specifically from an owner perspective and also return on investment. And I have, and we're addressing that. I want to tell you something kind of exciting about that. But that is, turns out that's Brad has a section within his dissertation that talks about that dives into the data that owners need downstream and full life cycle. So we're pretty excited about that. Steve, guess what? On return on investment, I have a research student starting in fall. And guess what he's going to do? He's researching and I'm going to work with him specifically about how we would address return on investment. And he's not an engineering major. He's a senior. He's a finance major at UC Davis.
Oh, wow, that's probably even better, actually.
Yeah, I know. It was like, what? And he's a really sharp individual. And he was introduced, I think Anne knows him, and he kept showing up to meetings. And I said, and he showed interest, and I told him what we needed on return on investment, and he's very excited about it. So we're going to work out a process where he gets engineering credit for his research. We'll probably have him in fall and winter quarter, and so I'm really excited about that. So
yeah, fantastic! I'm looking forward to hearing his research too.
Yeah, and I'd like to introduce him to you, if that's all right, once he comes on board.
Oh, please! I was going to say if his research turns out as relevant as I'm expecting, we might ask him to come and speak to us. Although I'm sure students would hate to have to be asked to come to speak to NASA, but maybe I can twist his arm.
Yeah, I'm sure. That's a once in a lifetime for them. It's literally a once in a lifetime shot. They're just so excited about this. It's good to see everyone's energy, especially the young talent that's out there so excited about this. So upload significant works. That could be a paper that you write. It could be a white paper. It could be a paper in trade magazines or just things you come across. So please contribute. Now, Ph.D. dissertation. We have a new form there. Again, very easy to see. So we have a lot of PhDs. We have about 20, almost, not quite, but almost half of this group has PhDs. And I'm not one of them. But we acknowledge that everyone on this team has a very specific work that they've dedicated their life to. For dissertation, those are good reference documents because they've already been peer reviewed. They've already gone through a series of referenced reading and things of that nature. And PhDs, they are an expert, a world expert in their field of study. So if we could have PhDs go in and fill out what your dissertation was about and upload your dissertation. And if you want to put in there how you think it would relate to the theory, please do so. But don't worry about it. We'll go through it. If you don't have time or whatever, we'll go through it just by the title, and we'll thumb through it and see if there's any relevant sections that we'd like to roll your dissertation into the major work, or just sections of it. And then, of course, if we use any of your sections, it will be, of course, referenced to the author. So please, if you could do that, that'd be great. It's just good to see all of the titles of the dissertation as well. Okay, application relevance processors. I'm not sure what that one is. Application relevance. Do you know what that next one is, Anne?
Yeah, you've already mentioned it. It's just about the information that we're collecting from everyone and why it
Okay,
adds to
perfect.
the white paper. Just
Okay.
a quick clarification, all the information about the PhDs, the resource submission, all of that is in one form, and I have already put it into the chat. So thank you.
Okay, great. That also includes papers, research papers, again, on that significant work, because all of us have published, not all, but most of us have published papers in trade magazines or other white papers, things of that nature. So the more information we have, the better. Current updates. So we're behind on the white paper, but that's okay. We'll push or a basic review of a skeleton of the white paper for our next meeting, which is in 2 weeks. But I want to explain how the white paper is going to be utilized and what the purpose of the white paper is, which will help understand really the function of the white paper and how we have to supplement it with all of our experience. And if you could monitor the chat room, that'd be great, because I'm not going to have time to answer questions and stuff. After I'm done with this, going through the agenda, we'll start looking at some of the sheets on the Excel document that will have some visual components to what I'm talking about, of the function of the white paper. So just know I'm running behind on that. I'm the primary writer of the white paper, only just to keep the wheels on the wagon on theory. Then I'm going to explain how that branches off, and it includes all the trade specialists or all of the lens specialists, because it's going to be very difficult if we had several writers. I'm keeping the spirit and the integrity of all the input we've had, which is behind me on the board, and put it to electronic form, which we'll look at today. We're going to discuss the diagram, the electronic diagram, in a very high level, which is the general flow. Today, we're focused on work breakdown structure. So everything we're going to talk about today essentially is a work breakdown structure. And yes, it's complex, rightfully so. And there are constraints that we have to think about. And we'll talk about that here in just about a minute. Discuss work breakdown structure applied to NASA historical costs. All right. So this was sent out on the invite. Thank you, Anne, for getting that out. Amir, I believe you're online. Are you online? Dr. Amir Savinci?
Yes, Paul, I'm here.
Okay, thank you. Last week, or the last meeting, you had a very intriguing question. When we kind of answered it a little bit, but after thinking about it and really systemically thinking about how difficult work breakdown structures will be, I think it warrants a further discussion. Your question, do you remember your question? Because I don't want to mess it up a little bit, but you want to re-ask that question again, or do you?
Probably can remember the gist of it, but the general idea was that goes back to the work breakdown structure was that let's see first what has been done in NASA sending a rocket, let's say to the moon, um, and come up with the breakdown structure. What does it involve to, and then we can extend it to the moon habitat research that we are doing right now, and then we can see what are the component of what we are doing, and we can focus on each of them before getting too complicated into the detail. And just to add to that, yesterday I reached out to one of my friends, probably some of maybe Steve from NASA know him. Dr. Alireza Kazemi, he is like with the Arizona State University. He's directly working in one of the technology, which is the cementitious concrete, waterless concrete, 3D printing sort of things for building this habitat on the moon. And he referred me to a couple of like research that I'm going to share with Anne for our library sort of things. And there was a couple of like already existing platform that NASA is working on, that the autonomous construction, the in situ resource. So technically, what I learned was that look, we are not planning to take all the material from theirs, right? So we need to see what material is available on the moon and use those material first before exploring any other option. And there are a couple of idea option to do that multiple company are working with that, but the general idea is that to use of the in situ resources at the moment. But anyway, I'm sorry, I guess I got distracted. But the overall question was that, Paul, that we need to see what component are we talking about. One of them is that what material are we going to use, right? What equipment, is there any equipment? Probably it will be autonomous, right? Then it's very similar to the traditional construction estimating. We have material, equipment, we have labor. What type of labor are we talking about at the moon? Or everything would be autonomous. If we can do a work breakdown structure, as you mentioned, it probably helps us to just navigate through this system, and we can have the focus where it needs to be.
Very, very good. You bring up a good point also. Let's think about this for a second. You brought up, they were all great points. One response, and from my perspective, would be you brought up like material used and autonomous mechanisms or robots or mechanisms or whatever, whatever you want to say. And there's two points. One point would be, I think, having the systemic work breakdown structure and the hierarchy and symmetrical evaluation or flow of components and units come before isolating the material, because the material would be defined then in a section probably already defined by NASA. In there they have a 7-layer 7 hierarchy, 1 through 7. And then the other thing that you brought up, so that's downstream from my perspective, and again, maybe my perspective off, so please push back. The other thing you brought up really illustrates something. You brought up labor production, and I like the idea, and I sent out an email, Stefan. I think you were on that email, and Mark Hilberg, NASA, and then Jabu, just requesting maybe a non, more of a public, non, something that can be shared publicly. But some modern estimate from Complex that we can maybe take a look at and just kind of see a practical application. We have Jabu gave us an estimate, but it was from of a moon base, but it's done in the 80s. Well, things have changed since then.
Wow. I know there's been a lot of studies and estimates done, but I can't recall ever actually seeing the details.
Well, any project would work, not even Moonbase, because we just want to get an example of what does a complex project even look like once you get into their WBS and things of that nature. But maybe but if that's not you, we could reach out to somebody maybe that has connection with.
No, I mean that's probably us. I think we'd be appropriate to get it. Just a lot of that stuff tends to be sensitive, either contract sensitive, or
totally,
sensitive, and not necessarily shared.
Is there maybe there's something I don't know, maybe there's something out there that would be okay to that's not non-sensitive, I don't know.
I'm sure there's something out there. It's ironically, I bet if we look through court records, we'll find something that was submitted for discovery and was never redacted. Because there's been actually the first version of Siri I found out lately was based on the Enron papers, because it was the only collection of just regular people talking that was publicly available that they had access to. And that was because it was submitted to the court records and nobody put forth any of the paperwork to redact the private information.
Wow. That's a lesson right there.
Yeah. So and of course there was a lot of not necessarily the most ideal source of information, but it was a good first draft, and they've moved beyond that since then.
Okay. Yeah, that's great.
Yeah.
Well, we'll maybe poke around the court stuff, but if we can get some example, even if it was a budget that never happened, you know what I mean?
Yeah. So are you looking at I guess RS means level of detail or more general level of detail?
No, I think Amir, can you chime up on
absolutely,
this? Because there was your request.
And RS means level of detail would be great, but I don't think we have something available to that detail. Is there any? But in general, Steve, I think for any project that you guys are working on, if we can have the overall structure, for example, material, and it doesn't matter what project would it be, right? The technology that you're using, the fuel of the rocket itself, maybe the pad, right? The maintenance, those elements, if we can identify it, even before thinking about the cost per se, it really helps us to, make our mind more structured and look at them in a different level.
Okay, so you're looking at complex terrestrial projects as well as space.
That would be, yes.
Okay. Well, I don't want to say I can save you time, but it may be disappointing. We're using the same processes as industry. Different engineers and analysts, have slightly different processes. But I bring up RS means as an example because that's how we did cost estimating and most of the offices I've worked construction through.
Absolutely.
So we do that, and we always have to develop that independent government estimate based on the contractors. So we've done that. We've done time and material, and when the RS means matches the time and material, that gives us confidence that we did the estimates right. And then roll it in with contract overhead costs and everything, which is just for me as a regular citizen and taxpayer as well as a civil servant is just astounding, the amount of overhead and the cost that we end up throwing on these contracts in order to get through the bureaucracy and make them happen. But
Steve,
the real cost is the cost of business.
What's your regular overhead? I'm just wondering to hear. I'm with the Port of Los Angeles. I'm on the city side. Exactly similar process. independent cost estimating every time. You're going exactly through the same process, so it could make sense to me.
Yeah, well, it's not. It's when I say overhead, I mean overhead from the subcontractor is that's actually doing the work. We can do a pretty good cost estimate via means we got that in, and then to actually contract it and get it executed, we end up going through the government contracting office, which is labor and time, and they have a surcharge. And then typically we have a prime contractor because, being government, we can't always just go out to the low bid. And even if we do, we got lots of change orders and requests, and there's costs there that need to be factored in. But if we go through like an 8A, which we often do, giving preference to small minority-owned businesses, they have an overhead fee, and everybody wants to add all of their own level of management, and they have to give a scrutiny too. They can't just literally be a pass through, and it just all adds up to generally. I mean, my rule of thumb was whatever I thought the project would actually cost, I would double it because that's what I would have to budget to get it done.
That's very true on large scale projects.
Yeah, and that is just the cost of business. And that was true for really any. I don't even want to say complex projects. That was true for any projects. And the smaller ones, if they still required the same level of oversight processes, the safety, the QA, the audit, everything else, just frustrating. Where I would like pay a government guy to fly out to Japan and stand there watching a contractor work, and it was just
Really
it's frustrating. And yes, we tried to find better ways, and we just couldn't. That was why we ended up having to do that. But
thanks for sharing. We are doing exactly the same procedure. Yes, totally.
Yeah, and the laws exist for a reason. You can go through and see why the government has these processes and these requirements to for anti-corruption and all, but it does make everything else we do more expensive.
Yeah, and plus not all plus everything that NASA does is almost a one-off. When we build hospitals, we get everything, even though one hospital is different, mechanical systems are different, things of that nature. But everything is manufactured in mass. But NASA, everything is one-off. The screws specifically for a certain need and things. So that would be.
Well, yes. No, I'm speaking here less about NASA and more about some of the work that I've done in the past for other government organizations.
I see. Okay.
Yeah, I don't want to throw them under the bus on a recorded WebEx here. So, but yeah, a lot. Well, the terrestrial stuff. Yeah, there is some special things if we're dealing with cryogenics or other hypersonic speeds. I mean, there is some crazy mega engineering that goes into some of our facilities, but a lot of them are just facilities built the same way as any other facility. I mean, an office building is an office building. Power distribution is just scaled to meet the requirement.
Sure. And this is very good dialogue. Thank you. And then Dr. Amir Zavinci, his audio went out. So just to clarify, he's with the Port of LA.
Okay.
Yeah. So I think the state side, I think.
Port is a city.
City. Okay. All right. Okay. All right. Well, based on and so let's just dive into work breakdown structure, and I'm going to bring a couple things. I'm going to walk the team through a couple of very important parts of the NASA work breakdown structure handbook, so we can see the complexity. One thing is that, as I mentioned before, NASA has decades of historical cost, and which means that past estimates and past missions and things of that nature have a work breakdown structure. And the handbook was written in 2021. And when you go through towards the front of the book, it has a date where anything past a certain date, and I think it's 2021, it may be 2020, would be mandated to have the work breakdown structure in a very specific way. So I think it's prudent that when we're doing assessment of how we would articulate work breakdown structure that is suitable for, we're calling it absolute minimum variance, maybe 0% variance. I don't know. Probably wouldn't be zero, but hopefully close. That we are sensitive when we're doing our research and study, that we're sensitive to past projects that that NASA has already put in their work breakdown structure. That here is those would be the sections in green. And the reason is we want to be careful that a project in 2021, even though the code is going to be expanded, and I'll talk about that here in a second, but a project in 2021 can be fit or coupled as far as historical cost relevance. I know that can be a challenge because each mission has unique components to it. But even with that, so we want to, I'm proposing that we keep integrity of past work down structure. We understand that that the numbering system of the work breakdown is going to be after a certain section of their sequential numbering system. So as an example, the green would be historical mission, let's say. Now, why this is relevant is because even in terrestrial estimating, when we do hospitals, very complex, let's say a $2 billion hospital, you don't start from scratch, and nor does NASA. You know, they have a lot of historicals that they build from. They don't reinvent the wheel necessarily every single solitary time, certainly for complex things. Of course, they have, when we do a hospital, or I'm assuming if NASA does it, you know, there are things that you have to amend and bring in that weren't, that are unique aspects of whatever you're estimating. But hospitals, which are very complex, you don't start from scratch. You go to historical. Hopefully the historicals are organized in a way that will give you data. And then you build on past historical and framework structure of an estimate, because hopefully they talk. They're supposed to. So anyway, so we want to keep the integrity of past projects, and we should be sensitive to that. And we need to be very, we need to acknowledge that. And then as we add more, and we're going to go into the work breakdown structure handbook here, our very next step here. We'll hit the electronic document first, and then go to WBS. But think about this. For verification, there's going to be a three-dimensional XYZ component to a unit. So a unit understands, whatever that unit component or micro or macro unit understands, where it's supposed to be at any given time. And we can do this now with modeling. Presumably everything's going to be modeled. Return on investment, that's going to have its own section. Now, what's the challenge that we have? And we just keep going, you know, this thing can get massive. That's why we need computers to help us on this. And potentially AI, which we have experts on this team from several universities that are AI experts and estimating experts. But the challenge, and so the purple are supplemental beyond the current NASA, either past projects or future projects. So I'm going to move off this page. I'm going to go to another page just very quickly before I get there. Okay. So this is that board, which is all of our input over, you know, even beyond this time, even beyond the 6 months or so. That's probably 2 years of work with input. and then supplemented by conversations or input from this team. And this is crossed over electronic. Again, kudos to Anne for putting this together. But essentially, if you can see my mouse, the flow is the business case. And we're not going to talk about the business case right now or whatever. We're just going to talk about work breakdown structure. The work breakdown structure starts at the very beginning, even before we understand all of the technology that's going to be used in it. Work breakdown structure. And there's subjective, objective analysis, risk analysis, things of that nature. Well, all of these, the WBS is worked not only with the individual contractors, and those are called CWBS, as opposed to WBS, which is controlled by NASA. Well, it's all controlled by NASA. And as we're in the business case, the work breakdown structure arguably is, and NASA acknowledges as well, is that it's so important at the very beginning that the structure is put together that thinks about life cycle. Now, we're adding a lot of dimensions to our tracking mechanism because we have production analysis and means and methods that can go awry very quickly in a chaotic state of construction. Most of us are aware of the chaotic state of construction on major projects here on Earth. Can you imagine, you know, on the moon and all of the variables that could happen? That's why we need a very sophisticated structure that can recalculate predictive analysis and also move back to the beginning of the prediction and update, you know, update what we thought was going to happen to actually what happened. And then a root cause analysis can be, well, why was this a one-off, or is this going to happen a lot of times, or what have you? I'm going to remind the team that production, they're just not going to show up on the moon and just build a habitat. You know, there's going to be testing the technology. There'll be small projects probably at the beginning. And all of this is opportunity for historical costs, which is so important on Earth construction as well on mega projects. I'd like to remind everyone on the team that one of the main contributors of projects being over budget is not an adequate way of checking and verifying that gives the beginning of the life cycle the information that's needed and the girth of the information. So we're going to focus on work breakdown structure, because the work breakdown structure should be a two-way flow. At the end, kicks back to the beginning. At the beginning, you predict the end. All right. So enough said about this. We'll kind of go through you know, this in pieces, but right today, work breakdown structure. Now, I'd like to just take a very small pause, and I want to go through this here really quick, and then I need to get to going over the NASA paper or NASA stuff. So think of the white paper as a structure highway. So essentially, you know, it's going to explain the group's work on two-way flow and explain all of these you know, these avenues of expertise. So the white paper is essentially just explaining what the main theory is and application, what have you. And then you remember, we want everyone to go in and identify your expertise. And the reason is because all of those categories, and there's 11 or 12 of them, the white paper is only going to acknowledge what those are, but it's not going to get into detail. The white paper would just be, it would take a lot longer, and it would be so difficult to write, and it would be huge, and it wouldn't be read by anyone because it would be so big. So what the white paper will do is it's just really explaining the theory so we all have a consensus of flow. It'll be easier for peer review. And then we'll identify these 11 aspects of knowledge areas that are inherent within the theory. So the white paper will say, here's the structure, here's the work breakdown structure, and here's how it ties to the main theory. But think of it as an off-ramp. When you're on the freeway, there's an off-ramp. So you take the off-ramp, and there's always typically a stop sign. We're just going to take it, and at the stop sign, you can go 45-degree angle sometimes, or straight or left or whatever, and there's a whole other network of roads. This white paper is only going to take you to the stop sign, and it's up then to the experts to understand the complexity, not necessarily solving anything, but tying in more detail, more micro, macro information, and how that ties back in. Now, that will not be part of this white paper, but we do need to understand next steps. That's why we need knowledge area leaders. So, for instance, if we're going, the main theory, and maybe this one is work breakdown structure, it's only going to get to a certain point, and then to go beyond that, we need experts that are specifically theorists that with experience on that side, and it goes for pretty much everything. So this is a visual on what is the white paper for. It's to get us together thinking of the major structure of an estimate and full flow of verification and how complex it is, a network of information, a data transformation, if you will. Okay, I'm going to pause there. Are there any questions? Okay, I'm going to stop, share, and then what I'm going to do is I'm going to share again because I want to bring in, there we go. All right, I'm assuming everyone can see my screen. Yeah?
Yep, I see it.
Yes.
Thanks, Rajat. Okay, so this is in our primary reading. Look, this is just maybe I'm a geek, but this is exciting reading, folks. It's packed with information. It is very intuitive. It's very forward-thinking. It's completely different than the numbering systems we would use typically. It's much more, I'll use the word sophisticated. I'm very impressed with it. I know a lot of time and and energy and decades and decades of experience went into it. So with that said, we know we have to add sections, maybe even beyond the mandated 7 layers that they have discussed. I'm going down to some of my notes here. So we just have to be cognizant of there's the 7 layers, payload, spacecraft, and each of these have, extension to subdivisions, things of that nature. But these levels of breakdown are components within systems. So like for the construction industry, it may be uniformat moving into master format. And what we need to include other section is an XYZ knowledge of where these components are supposed to be. Risk analysis, predictive analysis, verification analysis, business case to a level of, return on investment, as Steve's point was back a while ago. So the reason it's important for probably everyone on the team, at least to scan through the first 20 pages. If you read the first 20 pages, fast reading, it will give you an idea of the entire book, which is around 60 pages. To me, it's fast reading. And I think you guys would slam through it, but at least get through the first 20 pages. And some of that is just lists and stuff like that. So you'll go through pretty fast, but you understand the requirements and why they exist with NASA. And we have to be cognizant of that. If we add or suggest something that isn't quite mandated by NASA, we have to be very clear about what is it exactly. why do we recommend a slight variance to that? And then specifically point out, in the specification, in this case, handbook, either on this or the estimating handbook, why we're, the rationale of suggesting another methodology. But something here, the NASA authorized numbering system, let me see here, called NASA structure. You have this language established by the project team must use NASA structure management scheme. You'll see this a lot where there are mandates of how we structure. And right now the mandate only goes up to level 7. And I would argue we probably need to go, if I had to guess, maybe 19 or 20. Some of this can be quite complex. Well, we're doing something very complex, and we're tracking and predicting something very complex. That coding could be infinite. So we may want to take the 7 layer very objectively and think of it in layers of components of a system and breakout components. But we'll be introducing other, not necessarily components, a physical, tangible thing, but 3-dimensional, maybe I'm trying to think in my mind, just temporal data or 3-dimensional location, things of that nature. I keep bringing up 3-dimensional location, but my mind's going blank here. So all work breakdown structures, no matter what, have to be approved by NASA. And there's a strict protocol so they don't move off their numbering system, and rightfully so. Here's a sample form. So they have a structure of how you implement parts of the work breakdown structure. And again, if we're dancing in that space, we really have to understand how that process works. And again, the first 20 pages of this will give you a pretty good idea. So here's something that I like also is that the WBS work breakdown structure is used, and it's used for technical reasons and also for business management as well. I would like to understand that better, me personally, going through the pages. But also it does mandate where they only go up to 7, and that's where I think our challenge is going to be, because we're again, I see this going way past 7 on the numbering. Just go. Again, I encourage you to take a look at this. We won't go into it in detail. Another thing is that dictionaries of WBS have to have a very, very stringent understanding of the meaning of the measure. Definitive understanding of exactly what it is and how it is numbers and how they communicate. Let me see here. We're almost done with this. And then this is an example, also work breakdown structure cross-reference matrix. This is something I think will be very, very useful. Again, this is from the NASA book. And you can see how the layers, there's 1, 2, 3, 4, 5, 6, and it keeps going down. There should be 7, but okay. So that's it for that one. So I'm going to take a pause, and I'd like to open up for discussion. I know we only have 5 minutes, but homework. No, there's no homework. Sorry, guys. That was a habit. But I'd like to suggest that at least get through 20 pages, scan the work breakdown structure, and that will give us as a collective, as a team, give us a lot of opportunity to figure out the work breakdown structure side of the equation. I'd like to pause there and see if there's any comments.
Well, actually, I can give you some insight into the work breakdown structure because I use that every day in my program. It's more aligned to how NASA handles accounting than how NASA does cost estimates, if that makes sense.
Interesting.
So when you get down to level 7, I have like a dozen different projects that we assign different L7, and we use that more for tracking. Some of those are, hundreds of thousands of dollars worth of effort, rather complex, multiple people, multiple vendors coming in, and they all charge against that, and then all the charges come in. So they're expected to have their own processes for cost estimations on their end for budget keeping. But when they actually charge to the project, when we disperse the funding to make those procurements to pay their salaries, it's tied to that WBS, and it comes into that same bucket.
That is really intriguing. Yeah. Very interesting. And I didn't really grab that from the WBS workbook. When I get into it in more detail, because I'm about 40 pages into it or something like that. And so maybe I'll reach that. But that's fascinating. But that also illustrates why we probably will need to expand past 7. Because this would be a traditional estimate that would focus on production analysis and a reference on what we think and what actually happened. And if we have the right coding on the original one, just like financial reporting, once we have that category figured out, it can go backwards to that section within the WBS and be correlated that way. That's like the parallel process. But I'm glad you chimed in on that. That's fascinating to me. So thanks for that. Is there any other comment?
No, just that is very important to the projects because that's how we travel. That's how we do everything else. So yeah, that way everything gets charged back to the proper project.
So
the proper line.
So if we go moon construction, do you think, let's say that, in the theory we have pre-launch, post-launch, implementation, execution. So let's say we're in execution phase. At that point, no one's billing, are they?
At that
business
point,
deal done?
That I'm not sure. I've never had any sort of insight into that level of operations. Like, astronauts are getting paid, they're getting salary, they're
right.
Things are happening, and I'm not sure exactly at what level that occurs.
Yeah. You probably would have support people, ground groups that.
Oh yeah, there's lots of ground group, all that stuff happening. Yeah. Different
maybe
programs,
they build,
different projects.
Right. And maybe they build components of monitoring. Maybe they build a NASA. Here's the month that we, manage the implementation of electrical infrastructure or whatever. But it'll be interesting. That's a dynamic we really have to sink our teeth into.
Yeah. I was going to say, I'd almost say it probably depends, right? Depending on like the statement of work and what's in scope for your program, right? It can be in or out of bounds for your work breakdown structure.
Yeah.
It's a consideration.
Say that again. I'm sorry.
Oh, just depending on how the statement of work for your particular program, whether it's in scope or out of scope, right? That would end up determining if it's supposed to be in your work breakdown structure and what kind of allocations you need from a either material or labor standpoint.
Yeah.
I was going to share something in the chat, and this is the right place to do it, but I was in NASA's publication site looking for this. On page 11, they actually, this was from the ASCE conference, they tried to do kind of a high level work breakdown structure for lunar construction. So
we may have that paper loaded up, but can you forward that over to Anne so we can review it and get it up on the site?
Sure. Yeah. There's a good graphic in here that just kind of gives some of the ideas of areas you'd have to focus for hours or material costs.
Yeah, it may be the same paper we have, but you're intriguing me like amazingly right now. So that would be awesome. Thank you. I also have a question for, oh boy, oh man. Oh, Amir. The university that you referenced, do they want to be part? Can you ask them if they want to be part of this study? We can just include them, more the merrier.
Absolutely, I can bring it up. Definitely, but I'll share a few researchers that he shared with me with Anne quickly, and I was just looking at what Rashid sent it to us. It's really intriguing. It's exactly has that work breakdown structure that we are looking
Oh,
for.
that's beautiful. Okay.
Yeah, the site planning, in situ construction material. That really is the gist of what we are looking at.
Oh, that's
Definitely,
perfect. Yeah.
I'll work on that. I'll let you know.
Okay, thank you. And that goes for everybody on this team. If you have a thinker in the industry that is academia or private sector or public, there are no brick walls around this group. We literally need input from all experts. So we have a comprehensive understanding of this. Let me see. Any closing? It's 2 minutes after. We got to close. Is there any general information or general questions that somebody would have or has? Okay. Steve, you're awesome. Thanks for your input. Amir, thank you very much and for your input. And I think that was Scott, or maybe, yeah, I think that was Scott. That gave that last part of any input as well. I think that was Scott. So thank you very much. Let me see here. So I'm going to move that we adjourn for this week. And by all means, if you have any questions or you want to continue a conversation and you want to get some of our experts together or whatever, we can facilitate a side room talk at any time. We don't have to wait 2 weeks on it. So I'd like to offer that to the team as well. By all means, reach out via email and we can connect you to the right area leader. Hopefully next week we'll have a pretty good structure of the white paper that we can start talking about. Okay. Thank you very much, everybody. Have a wonderful weekend, and you guys are all amazing, and I'm blessed and privileged, I feel, to work with such this astonishing group. So thank you for that.
Thank you.
Yeah, thank you. And everybody have a great weekend and see you next time.
Thanks, Paul. You too.
Thank you.
All right. Thank you. Bye-bye.